So good day, class. So today we're going to discuss a bit about underwater construction. So I think this picture is an example of a stadium um, beneath an aquarium. So it's important for us architects to have at least an idea on how underwater construction works. So during the construction of bridges, dams, or any other structure where foundation part of the structure is mostly likely to lie underwater, we have to opt for underwater construction. So construction in water poses many difficulties, especially in the places where the depth is considerable. So during underwater construction, our main objective is to create a dry and water-free environment for working in such a manner that the structural ability of the structure is not compromised. So these are the classifications of underwater construction. So construction techniques and methods of placing concrete. Underwater construction techniques, you have caissons and cofferdams. Then the methods of placing concrete, you have the tremie method, the pump method, the toggle bags, and the bag works. Okay, so I'll only introduce you to some of these methods, class. Then in our activity, I think I will require you to discuss them. Okay. So caissons, I'm not so sure how to pronounce this. It's caissons or caissons. So I leave it up to you. So caissons are the structure used in underwater construction work consisting of an airtight chamber open at the bottom and containing air sufficient pressure to exclude the water. Okay, this is an example of it. So these are the types of caissons. You have here the box caisson, the open caisson, and the pneumatic caisson. So this is an example of a box caisson. So here you can see it's shaped like a box. You have here the water. You have here the earth. So it's not very clear in our PDF class. Okay, this is an open caisson. So this is the concrete seal. This is the cutting edge. Okay, and this is the plan. And this is an example of a pneumatic caisson. Here you can see the winch drum, the main lock, the shaft with ladder or rift, then the airlock. This is the working chamber. This is the compressed air, it's the hoisting rope or cable, it's the compressed air pipe, and it's the muck bucket. Later on class, since this is only in 2D, I'll show you a video on how caissons work. The next are cofferdams. So a cofferdam is a type of watertight construction designed to facilitate construction projects in areas that are normally submerged, such as bridges and piers. So when you say piers, that's another term for column. So the types of cofferdam, you have cantilever sheet piles, braced cofferdam, double wall cofferdam, cellular cofferdam, earth embankment, and rock fill cofferdam. So this is an example of cantilever sheet piles. Here we have the dredge line, then the sheet pile wall. You have here the strut. You have here the working area. So class is what happens when you do a braced cofferdam. Okay. So this section will be isolated once it's completed. Then you also have the double wall cofferdam. So here you can see the tie rod. This is the fill. This is the beam. This is where the working area will be. This is the sheet pile. Then this is an example of a cellular cofferdam. So cellular cofferdam is the outboard face, the phreatic line, the inboard face, the berm, the fill, and then the in situ soil, and this is the water. Then you also have what you call an earth embankment. So here you can see this is the load, this is the embankment, this is the drainage layer base, this is the weak consolidated layer, this is the stiffer permeable underlying layer. You have here the rock fill cofferdam. Here you can see the riprap, then the rock fill is where the working area will be. So the water that is side. Okay. Then let's discuss also the methods of placing concrete. We have the Tremy method, the toggle bags, the pump method, and the bag works. This is the Tremy method. So the hole is excavated by drilling. Then slurry is added into the hole. So drill, stabilize. Then the hole is cleaned. Then the rebar cage is positioned. Then concrete is then placed. You also have the pump method. So let's compare. So toggle bags and bag works. So toggle bags are ideal for small amount of concrete placements. And the bag is filled in the dry with wet concrete. It is used for repair work and then the concrete is squeezed out by a driver. So bag work, bags are made of open weave material. Then diver handled bags are usually of 10 to 20 liters capacity, but 1 cubic meter bags can be placed under a crane. Then we also have what you call trenchless technology. So trenchless technology method includes all methods of installing or renewing underground utility systems with minimum disruption of the surface or subsurface. So trenchless technology consists of various methods, materials, and equipment for inspection, utilization, and rehabilitation. So then, trenchless technology has become popular for underground utility construction road crossings. In recent years, there has been remarkable progress in development of new trenchless technology equipment and methods. So the objective of the trenchless technology, it's cost effectiveness, ease of design, production rates, extend underground assets, and benefits the environment. So let's go to site investigation. Common problems at site are the loss of invert walls, sealing due to corrosion, the leaking of joints, settlement, shape deformation, inadequate flow capacity, voids in embankment around and above the culvert. So hence, before the trenchlets excavation work at the site investigation has been made. So these are trenchless techniques in pipes. These are an example of the piping. Also have techniques in laying of pipes, the pipe jacking. So the term pipe jacking can be used to describe a specific installation technique as well as a process applicable to other trenchless technology. Then you have what you call auger boring. So if there are longer borings to be carried out or if the drilling precision has to be higher, the borings are carried out as guided auger borings. Then we have micro tunneling. So pipes are jacked from a launch pit to a reception pit by means of a hydraulic jacking station in the launch pit. Then you have utility tunneling. So the procedure consists of four major steps. First, you have soil excavation, soil removal, segmental liner installations, and line and grade control. Then you have pipe ramming. So pipe ramming involves the use of the dynamic force and energy transmitted by a percussion hammer attached to the end of a pipe. So there are also advances of trenchless technology. The expenses and dates are much easier to calculate. Surface life stays mainly undisturbed. Up to 95% lesser load for landfills due to minimal excavations, then small stress for streets and traffic, then the minimization of CO2 emissions. So nowadays, there are many new innovative materials that are being invented and many new materials are being researched. So new innovative thinking and new invention is necessary to save our valuable time and energy. So some of the innovative materials are listed here. You have fly ash bricks, translucent concrete, sensitiles, liquid granite, carbon nanotubes, underfired clay bricks, bendable concrete, Richlite, radiant barriers, transparent aluminum, carbon fiber, and solar panning roofing tiles. So what are fly ash bricks? So fly ash bricks are building materials containing Class C fly ash. So in India, fly ash was first used in Rihad Dam, which is located at Pipri Sonhadra district in Uttar Pradesh. So the composition of fly ash bricks are fly ash, lime, gypsum, sand, and cement. So these bricks are environment friendly and can be manufactured at the construction site itself. So these are the examples of fly ash bricks. So here in the Philippines, bricks are not common building materials. I think the most common you to use here are CHB or concrete hollow blocks. Then you have what you call translucent concrete. So they have been developed by a Hungarian architect Aaron Lonsonci. I'm not so sure how to read this. So it is mostly same as the regular concrete, visually appealing by mixing concrete with optical glass fibers, and thus the result was light transmitting concrete. So the glass fiber in the concrete act like a slit and carry the light across, and the light carried maintains its original color. So it carries the same amount of light around it no matter how thick it is. So this is an example class of translucent concrete. So you can just imagine you can do a lot of things if you know these materials, especially in your designs. Then let's go to sensitile. So if you walk across your kitchen, the floor to get something from the refrigerator, the floor twinkles with light path that guides your way through the dark room. So the concrete of the tiles embedded with acrylic fiber optic channels that transfer the light from one point to another. So as a shadow moves across the terrazzo surface, the light channels flicker with a randomized pattern, I think. So this is sample sensitiles. So this is something that's new to me. So liquid granite. So the material is lightweighted and has the same load-bearing capacity of cement, but is made of recycled materials. So liquid granite is not only a fire resistant beyond 1100 degrees Celsius, it can also withstand high temperature for long periods. So it has moisture resisting properties also. So this is example of liquid granite or granite. So it will depend how you're going to pronounce it. Then we also have carbon nanotubes. So it is heralded as one of the top 10 advances in material science over the last 50 years. So the projected sales of carbon nanotube would exceed $2 billion with less than 10 to the power of 3 metric tons annually in the next 4 to 7 years. So its major uses are in electronics and composites. Then you have unfired clay bricks. So unfired clay bricks are made up of earthy materials and are air dried instead of fire like conventional bricks. So it's eco-friendly and with additional construction properties. So it has the benefit of reducing the energy used in manufacturing and increases strength and decreases shrinkage. So this is an example class of unfired clay bricks. Then you have bendable concrete. So it's a new type of fiber reinforced bendable concrete which is used in various spaces. So this new concrete is 500 times more resistant to cracking than the regular. So the fibers slide in the concrete when bending occurs, providing with it is enough to prevent breakage. So this is an example class of bendable concrete. Okay, so it looks interesting, especially when you use it in construction. Okay, so I'm just amazed with the picture class. So imagine if you have projects that are bended already. Okay, then you use the properties of bendable concrete to form um, new designs. Then you have Richlite. So it is a dense material made from partially recycled paper and phenolic resin. So the 70% of the material is made recycled paper. It's high strength and has resistance to temperature up to 350 degrees Fahrenheit. So this is an example of Richlite. Okay. Then you have radiant barriers. So it can be applied anywhere in attic space of the house. It keeps heat out in summer and warm in during the winter. So it is usually made up of aluminum. Radiant barriers are widely used in many areas. Okay, so this is something new also to me. It's a transparent aluminum. So it is extremely durable material with excellent optical transparency. Be used for windows, domes, plates, rods, and tubes with a wide range of sizes and varieties. So outstanding strength and hardness. So it is cost-effective and advanced material solution. Is used in aerospace, security, defense, energy, and consumer products. So this is an example of transparent aluminum. So how you use the material class will just depend on your imagination. Then you have solar panel roofing tiles. So it transforms the solar energy into usable electricity which is required for our homes. It receives rebate from the government for installing them. Then solar panel roofing tiles are play an important role in our field or profession. Then you have carbon fiber. So carbon fiber is made up of carbon strands that are thinner than human hair. The strands can be woven together like cloth and then that can be molded to any shape you might want. Carbon fiber is extremely strong, lightweight material. It is five times strong as steel, two times as stiff, and weight is about two-thirds less. So, several modern construction materials have more strength, hardness, toughness, and durability. For example, fly ash bricks have these characters when compared with normal bricks. From the above discussions, the modern materials are mostly used all over the world. We can make our nation as high-tech using these innovative materials. Okay, so let's view class this video on underwater construction.
Placing of concrete part 5. Underwater concreting. In the past few videos, we have seen placing of concrete in different locations. The most important and difficult location for placing concrete is underwater. In structures constructed near coastal areas, concrete is often required to be placed underwater or in a trench filled with the bentonite slurry. In these cases, the concretes are generally placed with the help of bottom dump buckets or tremie pipe. In the bottom dump bucket, concrete is taken through the water in a watertight box or bucket. Once it is reached to the final place of deposition, the bottom of the bucket is made to open by some mechanism and the whole concrete is dumped slowly. In this method, some of the cement in the concrete is washed away, which causes the reduction in the strength of concrete. In some cases, dry or semi-dry mixture of cement, fine and coarse aggregate are filled in cement bags and deposited on the bed below the water. This method does not provide the satisfactory result as the concrete mass will be full of voids interspersed in the gunny bags. The most widely and best method of a placing of concrete underwater is by the use of tremie pipe. The word tremie is derived from the French word hopper. The diameter of a tremie pipe is about 20 centimeters, capable of easy coupling for increase or decrease of length. Generally, the bottom end is closed with a plug or thick polyethylene sheet or such other material. A funnel is placed on the top end to facilitate pouring of concrete. The entire setup is taken in the water and allowed to rest at the location where the concrete is required to be placed. As the end is closed, no penetration of water is observed in the pipe. The concrete with a very high slump value of about 15 to 20 centimeters is used for filling the funnel. When the entire length of the pipe is filled up with the concrete, the pipe is lifted up and a slight jerk is given by a winch and pulley arrangement. As the plug or cover falls and concrete gets discharged, the process repeated till it reaches the water level. The advantage of this method is no compaction is required for underwater concrete, as it gets compacted by the hydrostatic pressure of water. This takes us to the end of our videos on placing of.
Okay, so let's go to uh, the next video is about the use of caissons. Okay, class. So let's see this video on the application of uh, caisson construction. I don't know how it's pronounced. It's caisson or caisson. So let's look at this one. I think they for this one it's an application they're using windmills and the water. Okay, so that's another video. Then let's look at another video class for Caisson. Okay, so this video class is about pneumatic caisson method to build emergency access in urban areas.
The pneumatic caisson method is widely used to build underground structures such as bridge foundations and water tanks. In the construction of the Chuo Shinkansen, this method is used for building emergency access in urban areas. A reinforced concrete caisson is built in advance above ground with a sealed working chamber at the bottom. During the excavation work, compressed air is sent to this working chamber to prevent surrounding groundwater from seeping in. When an empty cup is inserted into water upside down, water cannot enter the cup due to air pressure. The caisson works on the same principle. As excavation work progresses in the working chamber, the caisson is extended upward above ground. Through the repeated cycle of lowering the caisson and conducting excavation, structures are installed at the intended position. Since the pneumatic caisson method always builds frameworks above ground while checking the ground foundation, elaborate excavation work is possible. Also, since groundwater is suppressed with compressed air, the surrounding areas will not be affected.
Okay, so I think the second video is much better compared to the first video in relation to our lecture. Okay, class. So I think that will be it for our lecture for this week. So if you have any further questions or clarifications, you can contact me anytime. Then I'll be posting our activity for our subject at our group page. So stay safe because the number of cases of COVID in our city is increasing. Okay, so drink plenty of water, drink your vitamins, and try to be positive. You have to have a positive mindset in this pandemic. Okay, so see you next meeting, class.